Good morning, everyone. I'm Satya, and I'm honored to be a speaker at the Security Besides Athens 2024 conference. A quick introduction about me. I'm a senior engineer at Amazon in the brand protection organization. In my role, my team and I are dedicated to protecting the integrity of our website by monitoring and preventing infringements and counterfeits from being listed on Amazon retail websites. We focus on preventing the misuse of intellectual properties of brands, ensuring that our customers can shop with confidence, knowing that they are receiving genuine products. In building these systems, we leverage multiple LLMs, including multimodal LLMs, to accomplish this goal. Today, I am excited to share insights on leveraging LLMs for advanced AI applications. This topic is particularly relevant for my work at Amazon and specifically in brand protection organization, as these models play a crucial role in maintaining the integrity of our model, sorry, of our platform. Next, we'll look at today's agenda. Let's take a quick look at the agenda for today's presentation. We have a lot of ground to cover. Uh, I will start with an introduction to large language models. This section will provide a foundational understanding of what LLMs are, their significance in the field of AI, and why they have become so prominent in the recent years. Then we'll understand the LLM architecture a little bit, uh, explore how these models are built, the underlying technologies that power them, and the key components that make them effective at processing and performing tasks. Then, we'll also look at the methods for leveraging LLMs. I'll discuss how to use LLMs effectively by leveraging APIs, playgrounds, and in some cases, deploying these models for production use cases. I'll also cover how to customize LLMs to meet your specific needs by RAG and changing the fine tuning the model, and how to deploy these customized versions. I'll also touch upon how to create and use effective prompts to get the best results for LLMs. Then we will look at the constraints on using LLMs. Let's take a closer look at what LLMs are and their key components, capabilities, and applications across industries. Large language models are advanced AI models trained on extensive datasets to understand and generate human like language. These models are designed to perform a wide range of language related tasks, making them incredibly versatile and powerful tools in the field of AI. The key components of LLMs are transformer architecture, pre trained parameters, and fine tuning, the concept of fine tuning. At the heart of LLMs is the transformers architecture. This architecture allows the model to handle long-range dependencies in text, making it possible to generate coherent and contextually relevant responses. Pre-trained parameters. LLMs usually comes with millions, billions, and sometimes trillions of pre-trained parameters. These parameters are learned from vast amount of text data, enabling the model to understand language nuances and contexts. Claude Opus is rumored to have around 2 trillion pre-trained parameters. The more the number of parameters, uh, the more the better the model at understanding the language. Now, let's dive a little bit deep into the transformers architecture. The transformers architecture is a game changer in the field of language models because it overcomes the limitations of previous models, like recurrent neural networks and long short-term memory networks. RNNs often forget most important information from earlier in a sequence because they process words one by one, which can make them slow and less accurate for long texts. LSTMs help by trying to remember better, but they are still slow because they also handle words one at a time. The transformers architecture overcomes these limitations, and it was first introduced in the paper called Attention is All You Need by Vashwani and others. The key components of transformers are self-attention mechanism, positional encoding, feed-forward neural networks, encoder-decoder, multi-head attention, layer normalization. Here is the transformers architecture picture from the paper that was published by Vashwani and others in 2017. This is this part is the encoder and this part is the decoder. And self-attention mechanism. Think of self-attention mechanism as a way for the model to look at all the words in a sequence and decide which ones are most important when figuring out what each word means. For example, in the sentence "the cat sat on the mat," the word cat might pay more attention to word sat and mat because they are closely related. Then position coming to the positional encoding, since transformers do not inherently understand the order in which the words are in a sequence, uh, the encoding is used to provide that information about the position of each word in the sequence. The next part would be feed forward neural networks. After applying the self attention and positional encoding, the process tokens are passed through feed forward neural networks within each layer of the transformer. These feed-forward neural networks consist of multiple fully connected layers with nonlinear activation functions, enabling the model to learn complex patterns and representations from the input data. Now the encoder and decoder. These are these are represented here. Uh, the encoder processes the input sequence while the decoder generates the output sequence. Each encoder and decoder layers contain self-attention and feed-forward neural network sublayers, along with additional normalization and residual connections. One other important uh, part of the transformers architecture is the multi-head attention. The multi-head and attention feature allows the model to focus on different parts of the sentence at the same time, helping it to understand the text better. For example, one part of the model might focus on nouns while another focuses on verbs in a translation task. To enhance the learning capacity and capture different types of information, this multi-head attention is used. Then comes the layer normalization and residual connections. These, these help stabilize training and ensure the model learns efficiently by allowing information to flow smoothly between the layers. Now, with the with the understanding of the transformers architecture, let's see how we can leverage large language models in our day-to-day or in our application building process. For developers, integration in applications is one of the ways you will leverage large language models. There are multiple ways of integrating large language models into your applications, starting from easy to somewhat of a difficult method. One easier way of integration, and we will look more into those specific things in the upcoming slides, is API and SDK based offerings. You call an API and you get the response. You don't have to host a model yourself. There are APIs and there are playgrounds to achieve the functionality you need. Then there is for production use cases or for high throughput use cases, you traditionally want to deploy the model and maintain the model yourself. So you have greater control over the fine tuning process and all those. So in there are few options where you can deploy the model into your uh, in, into your uh, machines, and we'll see those. And we will also see how you can basically uh, deploy a fine-tuned model with your custom inference code. Then there are there are playgrounds which will help you basically in deciding or running quick checks on uh, or understanding how the model performs or what's the expected outcome of a particular model. Some of the playgrounds that we have today are uh, ChatGPT, which everyone knows. Then there is AWS Bedrock, offered by AWS, uh, where they have playgrounds for uh, multiple foundational models like Mistral, Claude, uh, Llama by Meta. And you can also build quick UIs with Gradio with lot less code, uh, and that helps you in experimentation of these large language models. For non-developers, the playgrounds and maybe with little coding background, you can probably come up with quick UIs with Gradio, and or you can use Bedrock, ChatGPT, and Claude AI. Now look at the first way of using LLMs via API integration. So here is a way to interact with Anthropic's Claude V2 model using AWS Bedrock APIs. It's a simple enough code that you can basically integrate into your applications if they are built on Python. There is an equivalent Java SDK to uh, invoke the model and get inference. So uh, you initialize a Bedrock runtime client using the Boto3 Python uh, implementation and provide the prompts, and you give the model ID and content type in which you wanted to see your response, and then invoke the model. Uh, this is a this is a straight way to get the response from the model without having to host the model yourself into your infrastructure. Some of the model types that are supported on Bedrock today is for the text-based models like text classification or text understanding. You have Jurassic 2, Titan Text, Claude V2, which is the popular one, Claude Opus, Claude Sonnet, and all those things from Anthropic, Command R and R plus from Cohere, Llama 2 and 3 from Meta, Mistral, which is another popular one from Mistral AI. For the image generation, it's technically not LLM, but for as part of the umbrella of Gen AI in general, for image generation, there is Titan Image Generator, Stability AI, Stable Diffusion, where you can give text-based prompts to generate images. For the multimodal LLMs, where you have images as well as text or queries as part of your prompts, you have Claude 3, Haiku, and Sonnet from Anthropic. Uh, these are hosted on AWS infrastructure. You don't have to host it yourself. All you need is just invoke the model using the model ID, and uh, by creating the run the client using their uh, SDKs. There are embedding models also for similarity based search is kind of a use case, uh, like Embed by Cohere and Titan by Amazon. If you are if you want to experiment, there are chat playgrounds as well. Uh, Here is one of the AWS Bedrock's chat playgrounds for Claude. Uh, all you have to do is enter your query, uh, and ask some relevant questions, and then hit on run. They charge you by the number of tokens that they process. So it's basically a playground to experiment with large language models and see if a particular large language model fits your use case. Here is one of the playgrounds for Anthropic. Uh, then here, one interesting thing about this example is Anthropic can you can provide a document or the content in the document and format your uh, query in such a way that it kind of gives you a response based on the format that you have asked for. We'll go more into some of the prompt engineering techniques where you probably would get a good idea on how these prompts would be constructed to get more efficient response from the LLMs. Hugging Face is another popular uh, model hub where you can basically uh, run your inferences or do experimentations before actually deploying the model onto your infrastructure. Uh, uh, we'll go through some examples of how you can use Hugging Face uh, shortly. Here is a quick demo of Hugging Face. There is a model hub in Hugging Face where you can probably pick some of the models. There are quite a bit of models that are registered in Hugging Face. But let's pick Llama 3. So you have uh, you can train this model or you can deploy this model into SageMaker or one of the popular cloud service providers. Or you can directly use Hugging Face to basically uh, uh, deploy it to your deploy it in Hugging Face. Hugging Face can provide a dedicated endpoint to you uh, by hosting the model in one of these cloud service providers. Mistral instruct. Yep. So the Mistral 7 billion parameter model. Uh, so, for example, for quick playground kind of an experience, you can probably do this way. Uh, you can ask your questions uh, like, what is Hugging Face as part of quick experimentation? It gives you the responses so you can try it out. Uh, there is a inference API which is serverless. Basically, you can create your own API keys and use this code to basically call any model that is supported by Hugging Face. Uh, you can manage your tokens. These are the tokens that I use. You can create a new account and have a set of new tokens that gets generated. So you'll be charged according to the based on the token ID and the number of requests you put. However, the inference API serverless, I believe, is free. You don't have to pay for it, but it is not recommended for production use cases because they don't guarantee the availability. But this can be used for quick experimentation of sorts. Uh, Now coming back to the slides, here is one more model that is on Hugging Face, which detects the image and segments the image uh, and identifies what all are present on the image. This is the serverless request inference serverless inference request that we have seen in the demo. This is used for prototyping, but not for production use cases. Then you can host the models on for production use cases. You can directly host the model. This is one more thing that we have seen where you can deploy the model on a dedicated endpoint uh, with hosts backed by SageMaker or AWS or Azure or Cloud, Google Cloud, sorry. And if you want to deploy the model yourself onto the SageMaker, into your own account, into SageMaker on the AWS SageMaker service, here is a sample code where you can probably, which you can use it in a Jupyter notebook to deploy the model directly into your SageMaker service. Uh, all it needs is the Hugging Face model ID. In the model hub, you will have the access to Hugging Face model ID. Then you can name what is the task that you want to perform, uh, and then on which instance type you want to uh, load the model. It creates an endpoint, and the endpoint you will be able to invoke the endpoint with any SageMaker runtime client. Uh, Similarly, there are other ways to invoke or deploy the models into Azure and Google Cloud. Uh, you have the code on how you have the code on how to deploy this particular model into the Azure or Google Cloud uh, listed in the Hugging Face documentation or under this deploy button. This is one more thing that we have looked at already as part of the demo. This is for deploying Microsoft's Phi 3 Mini into a CPU. You have a way to compare costs across multiple cloud service providers, and pick a particular instance. You can also set the auto scaling uh, to better account for the costs. Uh, there is another popular solution for hosting models by using AWS SageMaker Studio, where you have a bunch of foundational models, and you have button at the click of a button, you will be able to deploy it into your own SageMaker AWS personal accounts or the service-based service accounts. If you want to deploy, if you have a fine-tuned instance of the foundational model, then you have multiple ways of deploying those. For some of the foundational models, AWS Bedrock will allow you to fine-tune it by providing UIs that are targeted for providing your fine-tuned data set. Uh, do check it out. And they offer fine tuning for Llama, Titan, and Command models. Uh, you can import your custom model also in the Bedrock, but currently it is supported only for Mistral, Flanty 5, and Llama architectures. You can also build a synchronous or asynchronous endpoint on SageMaker via SageMaker SDKs. If you have your model artifacts, you should uh, put your model artifacts in the tarball, and then have this inference code which can load your model into the uh, inference code which can load the model artifacts and then create a model and then run the inference using this piece of code. This is one more easy way to deploy models and customize your inference code in such a way to handle a little bit a small amount of customizations based on your needs. Now we will go into the limitations of standalone LLMs and why do we need some other techniques to address the limitations of standalone LLMs. First, the LLMs can produce content that is inaccurate or completely fabricated, known as hallucinations. This can be problematic, especially in applications requiring precise and reliable information. Secondly, the LLMs struggle with providing up-to-date information uh, because they are trained on data available up to a certain cutoff point. Any developments or changes that occur after the point won't be reflected in their responses. Another challenge is that general purpose LLMs often have difficulty handling domain specific queries effectively. They might not have specialized knowledge needed for specific industries or fields without further customization. Limited contextual understanding is also a concern. LLMs may not have grasp of the full context of complex queries or conversations, leading to responses that are off target or incomplete. Ethical and bias issues are significant as well. These models can sometimes produce biased, or ethically questionable outputs, reflecting biases present in the training data. Lastly, fine-tuning large LLMs to improve their performance for specific tasks requires substantial computational resources, which can be costly and time-consuming. To address some of the limitations that I have discussed in the previous slide, we use a system called RAG. RAG, also known as Retrieval Augmented Generation, is an advanced AI approach that combines the strengths of retrieval systems with generative models. It aims to enhance the capabilities of LLMs by grounding generated responses in factual information retrieved from knowledge bases. How RAG works? RAG has two components: the retrieval component, which is responsible for fetching relevant documents or pieces of information from a predefined knowledge base based on the user's query. Techniques such as keyword matching, semantic search, or vector based retrieval ensure accurate and contextually relevant information being retrieved. The second component is generative component. The generative model, typically an LLM, uses the retrieved information to generate coherent and contextually enriched responses. This integration allows the LLM to provide answers that are not only fluent and contextually relevant, but also grounded in factual data from the knowledge base. There are significant benefits of using RAG. First is the improved accuracy. By incorporating retrieved factual information, RAG significantly reduces the likelihood of generating incorrect or irrelevant content. This grounding in up to date, verified information enhances the overall reliability of the responses. Second, enhanced contextual relevance. The retrieval component ensures that the responses are highly relevant to the user's query, leveraging specific information from the knowledge base. The third one is overcoming the knowledge cutoff. The retrieval system can access the most current information, addressing the limitations of LLM's knowledge cutoff dates. This ensures that the responses are based on the latest available data, maintaining relevance over time. Other benefits are reduced hallucination. The risk of generating hallucinated or nonsensical responses is minimized as the generative model relies on actual retrieved information. With respect to scalability and efficiency, RAG enables scalable solutions by dynamically retrieving relevant information, reducing the need for frequent retraining of generative models. Now, now let's look into the implementation steps for RAG and how we can plug in the RAG system to LLM. So first step is to select a knowledge database. Uh, the knowledge base could be your internal company database. Just you have to ensure that the knowledge base is comprehensive, up to date, and well maintained. The second step is data preparation. You have to clean up the data, pre-process all the data in the knowledge base to ensure consistency and quality. You can host the data in various solutions offered by cloud providers, or you can probably have your own custom uh, database to host this knowledge base. Uh, some of the popular ones are AWS OpenSearch, uh, and Pinecone is another vector database that is used uh, prominently for RAGs. Then, in order to have the knowledge base up and running, you have to index the data using appropriate techniques to facilitate efficient retrieval. The most common way of storing the information in the RAG or knowledge base is storing the embeddings in a vector database. You can use multiple indexing techniques to store the embeddings to control your costs of hosting the knowledge base. Some of the popular techniques are IVF and IVF with product quantization offered by FICE engine, which is from Facebook or Meta. Then the next step is to develop the retrieval system. When when a user posts a query, you have to convert the query into some way to search the knowledge repository and get the relevant documents to pass it on to the LLM as a context. So here is where the vector databases will help a lot, where you can probably convert the query into an embedding and then do a semantic search or uh, onto the vector databases to get the relevant documents. Uh, some of the popular algorithms are KNN search to get the top X relevant documents for the user query. Now, the last step is to combine this retrieval process with the LLM. So once you get all the top results for the user query, use that as a context and send it as a prompt along with the question to the LLM. And now the LLM will use the documents from the knowledge base as additional context in giving you the relevant response. There are, apart from the limitations that I have discussed earlier for the standalone LLMs, there are cost concerns as well for using LLMs. Here is one example of how the costs look like for as part of the computational requirements. So this is picked from the AWS documentation. The Llama 3 model. Uh, Here are two models from Meta's Llama 3, 8 billion one and the 70 billion one. Uh, these require the 8 billion one requires G512x large, and the 70 billion one requires 24x large machines. Here is the cost that you're looking at. One instance of G512x large contains 4 NVIDIA A10G GPUs. The cost on SageMaker, cost of on AWS for running this instance type is $7 per instance and per hour. And for P4D 24x large, you have 8 NVIDIA A100s GPUs underneath it, and the cost of running that model per hour per instance is $37. There are costs associated to host a RAG, because if your knowledge base is huge, then you need an efficient way to store that knowledge base in and to make it available uh, for the LLM. There is operational cost and maintenance cost associated with the LLMs, because you have to regularly fine tune it and regularly update it and regularly scale it up in case your traffic increases. Here are some of the cost reduction strategies that you can use. Uh, First, you can use pre-trained models by APIs and services in order to reduce your costs. Don't have to pick the model, host it yourself. There are APIs available. If your traffic is too low, then popular solutions like AWS Bedrock, OpenAI offer APIs. You don't have to host the model yourself. You just call their APIs with the relevant prompts to get the results. This is a cheapest option if you are okay with the pre-trained model. Then, if you have to deploy the model because you want to control the cost and you have to uh, uh, provide LLMs as a high throughput service, inferences as a high throughput service, then you can deploy in the foundational models in AWS SageMaker and AWS Bedrock. Uh, then you can probably control your costs and the scaling requirements a little bit. Then you can also optimize the model size if you're deploying it on your hosts. You can optimize the model size by model distillation. It's model distillation is basically you transfer the learning to a smaller model from a larger model. Uh, then you can also apply quantization and pruning techniques to reduce the parameter size of the uh, model. There are pruning techniques available to clean up some of the weights of the model to significantly reduce the size of the model. Quantization, usually you can deploy it at the model at a lower precision from, let's say, from floating point 32 to floating point 16 uh, to reduce the overall uh, cost of hosting the model. It will reduce the size of the model as well. Then if you're deploying the model on your instances, think about auto scaling it. And if you don't have a need for synchronous invocation, try going with asynchronous invocation by batching the requests and then uh, inferring the requests in batches. And then uh, you can scale it down when there is no throughput. These auto scaling solutions are offered by almost all the popular cloud service providers. Uh, One popular solution is SageMaker from AWS, which default provides auto scaling, which is easy to configure. Then you can purchase some of the instances at a lower cost, and you can probably uh, uh, use spot instances if you're if you don't have to serve the traffic at 100% availability. Caching is another technique where you can probably cache some of the responses from the model and try to minimize the inference costs. It's with respect to RAG, uh, instead of using the HNSW, try looking at IVF flat or IVF PQ indexing techniques and compression for knowledge bases to store or indexing the documents as part of creating the RAG based systems. There is model cascading as well. You will deploy a series of models with increasing complexity and computational costs. So most of the requests go through the smaller size models which have lower costs, and then for those uh, uh, which are okayed by the lower models, in order to increase the precision, probably you can pass those requests through the larger models. So these smaller models will act like filters to reduce your costs. Now we will discuss about prompt engineering. Prompt engineering is about crafting inputs that guide the model towards the desired output. A good example of prompt, this is picked from the AWS documentation. It needs to have a good structure, the contextual information about the task, reference for the task, simple and clear complete instructions, and the instructions are placed at the end of the prompt. The format of the output is specifically described. This constitutes a good prompt wherein the LLM will be able to understand the prompt better and give you a most accurate results. Some of the examples of good prompts are for text classification prompts. You can use this. Uh, uh, you can use the prompt in this way. This is taken again from the Anthropic Claude's documentation. Uh, so here is one such prompt for text classification. You uh, you give a clear instruction to the LLM on how you want your output to be. Here is a question answer based prompt. You again give a clear instruction, ask pointed question on what you want. Here is one such example. For text summarization, this is one more way where you can give the whole text enclosed between the text and ask the pointed question around summarize the text in one sentence. Then there is code generation prompt, which is very much useful for every developer. Uh, this is one such template to have a good response. Now let's see how we can leverage LLMs as a software engineer or a tech professional. So firstly, uh, LLMs can be used for automated code generation, and it can significantly speed up development by handling repetitive tasks and providing code suggestions. For example, GitHub Copilot, Amazon Q, and AWS Code Whisperer can generate code snippets based on comments. The second is code review and debugging. LLMs assist in code review and debugging by identifying potential bugs, suggesting fixes, similar to tools like Deep Code and Code Guru. Then the next is document generation. LLMs are very good at generating documents once you paste the code into the prompts. They can generate detailed document strings, README files, and API documentation from the code base. Next is the natural language interfaces. You can build more natural language interfaces which allow for more intuitive software interactions, enabling users to perform uh, tasks using chatbots or voice assistants. For technical support uh, and troubleshooting, you can use LLM with AI driven chatbots that provide first level support, reducing the burden on human teams and improving response times. LLMs can also analyze data, generate reports, and extract insights from textual data, aiding in decision making and strategy formulation. Specifically in the field of cybersecurity, we can leverage LLMs for threat detection and analysis. LLMs can analyze large volumes of data, such as logs and network traffic, to detect patterns indicative of a cyber threat. This leads to faster and more accurate detection of cybersecurity breaches. Then you can also use LLMs in automating the incident responses. LLMs uh, can be used to trigger predefined actions by configuring the LLMs with the help of agents that can take the actions. They help in quickly mitigating threats and minimize damages. In the phishing detection and prevention, by analyzing emails and communications, LLM can identify and flag phishing attempts. This reduces the risk of successful phishing attacks and enhances email security. In terms of vulnerability management, LLMs assist in identifying and prioritizing software and system vulnerabilities by analyzing code repositories and security bulletins, leading to more effective vulnerability management. User behavior can also be monitored and analyzed with the help of LLM, and it can detect anomalies and potential insider threats. Coming to the real world examples, here are some of the examples for how Amazon used LLMs to serve the customers. So when you open the Amazon website, you can basically see the review highlights where it summarizes the reviews given by all the reviewers into a small condensed form of review. Then it also helps sellers to generate content for selling their products with very little information, and saves time for the sellers and allows for more uniform creation of products and fills the missing details. Amazon Pharmacy deployed the LLMs to answer questions more quickly because uh, they use a knowledge base which is fine tuned with all the internal wikis and uh, other sources of information about the prescription drugs, and then summarize the findings so that customer requests are addressed quickly. And finally, uh, thank you for this opportunity, and hopefully I was able to provide information for your uh, in aiding your pursuit to leverage LLMs to a greater extent. Thank you.